Welcome to the Explainer. Trying to break into the semiconductor industry, it can feel like you're drowning in information, right? There's just so much to learn. So today, we are going to cut right through all that noise. We've got the ultimate roadmap to help you land that dream job.
So here's the thing. The biggest mistake, and I mean the biggest one people make, is trying to study literally everything. According to our source, the whole hiring game has completely changed, especially since 2024. Those old methods of just learning a little bit of everything, they just don't cut it anymore.
All right, so here's our game plan. We've got this 5-step roadmap that's going to take you from totally confused to crystal clear. We'll start with the new hiring reality, build your essential toolkit, help you pick a side between front-end and back-end, then show you how to master your domain, and finally, how to prove it all with projects.
Okay, first things first, we have got to understand how companies are actually hiring people today. Because seriously, if you miss this part, everything else you do could be a total waste of time.
So what's the big change? It's this massive shift from general hiring to what's called domain-specific hiring. See, back in the day, companies would just hire a big bunch of new grads and kind of sprinkle them around wherever there was an opening. But that's all changed. Now, the actual teams, the verification team, the physical design team, they hire directly for their own specific needs. They want specialists who can come in and contribute from day one.
So, how do you become one of those specialists they're so desperate to hire? Well, it all starts with building a rock-solid foundation. Before you even think about picking a path, you need to nail the skills that every single role in this industry is built on.
Yeah, our source lays out 10, count them, 10 absolutely essential, non-negotiable topics. Think of these as your golden ticket, your entry pass to even get an interview. We're going to break them down into 3 core toolkits to make it super simple.
First up, we've got the hardware core. This is the bedrock, the absolute ground floor of everything. You've got digital electronics, that's your gates, your flip-flops, the basic building blocks. Then Verilog, the language you use to actually describe and build complex hardware. And of course, CMOS, so you understand how the tiny physical transistors that do all the work actually function.
Okay, next layer up, the system view. This is where you zoom out a bit. You need computer architecture to understand the big picture of how a processor works. You absolutely have to master static timing analysis, or STA, to make sure your design can run fast enough. And yeah, good old C programming. Its logic is foundational, and it's still super important, especially in verification.
And finally, let's put the finishing touches on this foundational toolkit. You've got to understand the basic ASIC flow, the whole journey from idea to chip. Low-power design is huge now. Everybody wants their batteries to last longer. Scripting, especially with Python, is a superpower for automating tasks. And don't sleep on aptitude and puzzles. Interviewers love to test your raw problem-solving chops.
All right, so your foundation is poured. It's solid as a rock. Now comes the big decision. It is time to specialize. And really, the first huge choice you're going to face is front-end or back-end.
This little table here just nails the difference. Let's break it down. Front-end, that's all about logic and architecture. You're basically coding the brains of the chip. Back-end, that's about physics and layout. You're the one turning that code into an actual physical thing. So the real question you got to ask yourself is, do I get a kick out of coding the design, or do I love the puzzle of actually making it a physical thing? Okay, path chosen. Now it's time to go deep. This is the step that separates the good candidates from the ones who get the job offer. The great ones.
So if you picked front-end, you're going to be diving headfirst into RTL design and verification. Think of it as coding the chip's brain and then being the detective who finds all the bugs. If you went back-end, your world becomes synthesis and physical design. You're the architect turning that code into a real, manufacturable blueprint.
So, for all your front-end folks, this is your new Bible. You're moving past the basics of Verilog and into mastering System Verilog and this thing called the Universal Verification Methodology, or UVM. And let me tell you, UVM, that's a game changer. Mastering that is what really separates the pros from the amateurs in the world of verification.
And for my back-end crew, these topics are about to become your best friends. You're going to be eating, sleeping, and breathing concepts like the place and route flow, and optimizing for power and area. And hey, pay extra attention to clock tree synthesis, or CTS. Our source says this is an absolute favorite topic for interviewers to grill you on.
Okay, you've got the knowledge, you've mastered the theory, you're feeling good, but how do you actually prove any of this to a hiring manager?
This final step, this is where so many people stumble.
Your project is your proof. It is everything. It's not just some random line on your resume. It's the living, breathing evidence that you can actually do the work. And here's the critical part. Your project has to line up perfectly with the job you want. You can't show up with an amazing verification project if you're trying to get a physical design job. It just doesn't work.
The best kind of project, the one that really wows people, tells a complete story. It shows you can take an idea from its initial RTL code, meticulously verify it works, synthesize it into gates, place and route it into a physical layout, and finally produce that GDS file. That's the blueprint that gets sent to the factory. It proves you get the whole picture from A to Z.
And that brings us full circle, right back to the most important point of all. Think about that skyscraper analogy. Your super specialized skills in front-end or back-end, that's the tall, impressive building. But you can only build it high if it's sitting on that super strong 10-topic foundation we talked about. Without that base, the whole thing just crumbles.
So, the big takeaway here is simple. Stop the scattered, study everything approach. It's time to get focused, build that foundation, pick your path, go deep, and then build a killer project to prove you've done the work. That right there is the modern roadmap to breaking into the semiconductor world. So the only question left is, your foundation is set, your path is chosen, what are you going to build first?